Hello friends, good to see you everyone. Super excited to be here with Robert and David in person. Had a challenging year, but we're happy to be in person again. Thanks to everyone for joining us through this challenging year. I hope you're doing well. Robert and David, to our awesome community watching us now.
Look forward to more deep learning adventures.
Yes.
Hope to see you in person soon.
Awesome. Have a good day everyone. We love you, appreciate you. See you next time. Bye bye. Alright, welcome everyone. Another fun adventure and a surprise for you all. Finally met in person. Good to see you all. Hope you're doing well. It's been a crazy year. Hopefully as things are reopening up, we can see each other more in person, or at least see our family members and friends and have some good quality time together. We don't have a lot of participants today. Mike was the only brave one to join, but that's okay. We're going to do a quick round of a summary of what we covered in this specialization. It's been an interesting one, and then later on we're going to turn off the recording and we're going to talk a little bit about what upcoming projects we want to work on as a community. Robert, David, you want to say anything to our cool, awesome community?
Thanks for joining, everyone. It's exciting to be our first deep learning adventure that is at least partially in person.
Yeah, I would say it's been great for everybody to stick with us through these different adventures, and we got some great content coming in the future.
Awesome, awesome. Looking forward to it. Cheers to that. All right, friends, I'm going to share my screen here. And for those of you joining us from YouTube, welcome again. Thanks for sticking with us, and thanks for liking, subscribing our videos. This is a quick summary of what we covered in the different courses of the last data and deployment specialization from TensorFlow. This is just to motivate us in terms of what projects to think of, or what kind of data sets we looked at, and so forth. So this would be like a good summary for us to get an idea of what we worked on in the past. So I remember back in the days when Robert, I think it was you, was covering this handwriting classifier for us. That was an interesting one. I liked the interaction with the user part. I liked that the user could, I'm going to mute the video actually, I'm going to let him play a little bit. But the user basically could draw something. And I think this was a network that was already pre-trained, and you would do inference on the fly on your browser. So
Right. What we were learning in this lesson was how to build models that it could run in the browser.
Right. That was an interesting one. Welcome, Vladimir.
Hi, guys.
Good to see you. We're just doing a summary of the cool project we worked in the past for our community here. Yeah, this was a good one. I like this one. This was the very first intro to basically doing models outside of Python, outside of like heavy workstation data sets that we've seen in the past. Cool. And after that, we switched gears a little bit. I think, David, you covered this interesting data set. This was the Deep Weeds data set.
This is the Deep Weeds data set. And this was same kind of thing.
Chinese apple or zero. Just remember the label.
Sorry, I didn't get the video. I was like, are you here? How come you're there?
Yeah, so this was the Deep Weeds data set that's available from TensorFlow Datasets. And again, we were doing work in the browser with it.
Right. So you train a model in the browser, right? And,
yes.
And then you uploaded. Yeah, you uploaded different photos of different weeds, and it gave you the class number.
And this was all using TensorFlow.js.
Nice. And you can see a bit of part of the network here. Cool. I like that project too. After that, we tried a little bit of in-browser data collection and training. This was training a simple CNN network. But what I liked about this was that we were able to collect data. So we're able to take multiple photos of different classes. And I think this is like rock, paper, scissors, Spock, lizard, like an extended version of the classical game. And then obviously the more data we collected, the better. And obviously depending on what what I was wearing that day, if I had short sleeves or long sleeves and so forth. A lot of interesting concepts, but I like the fact that we were doing data collection in the browser itself. I found that interesting. And we trained the network there, and then we did prediction on the fly. That was an interesting project. So yeah, this was again TensorFlow.js. Welcome, Neil.
Hello. I see you guys are together.
Yep.
I know.
That's great.
See ya. Then I think we switched gears on the second course. We talked about deploying models on edge devices, specifically Android and iOS. And this was a nice app that I think the TensorFlow team had developed of doing image classification. So there's a camera here rendering whatever you're pointing at, and at the bottom here where you can see, it's giving you a classification of what item is it looking at. So I think it was like a razor. I think it's an eraser. Maybe it's getting confused by the shape of the pen.
What else?
It was a good one as well. I like the deployment on the edge. For my camera, I thought it was a projector. My mug, I didn't find it properly. Pencil sharpener mug. I think I got the mug. This was my previous apartment. Guinea pigs. I got the guinea pig. I think this was ImageNet. I don't know if ImageNet has guinea pigs or Seafire tank. Hamster. Yeah, close. But that was an interesting one because we're playing, with models on our device.
I think we were using ImageNet for the classification one, and this Coco dataset classes for the object detection one.
Right.
Cat,
Yep.
dog.
This one. So you're saying it was Coco probably, yeah?
Yeah.
So only 80 classes
80
to
classes.
pick from here.
Right. So I wasn't picking up my guinea pigs as guinea pigs. I was saying cat. This was an interesting one as well with the bounding boxes. I think it did well when I went outside. Yeah, I think it did well with cars. Not all of them, but most of them. And person somewhere, if I remember correctly. Yeah. There's a person there. It's some percentage. 56% sure. Nice. That was a good project as well. Then we switched completely gears again. This was course number 3, I think, with pipeline data services.
TensorFlow data services.
TensorFlow data services. This was by far for me the most content-heavy course, right? I had a hard time catching up with this one. So this is basically trying to write up efficient data pipelines. Could it be from data collection, not data collection, but data reading, preprocessing, transformation, anything that you can do efficiently and in parallel so you can feed it to a model. This was the main concept of this course. This one, as well as TF datasets, right?
I think so many of these courses, they start with the most exciting material, which for many people is learning how to train the models.
Right.
And you often tend to ignore or postpone the attention on something like the data engineering ETL processes that in many cases take much more effort to design and have to be made separately for each task that you do. So you spend a lot more time on this stuff. So it's good to have a course like this that showed a lot of the techniques that one can leverage to do this more efficiently.
Like this one, because usually we've seen this kind of pipelines from the scikit-learn perspective, right? Where we can see different, categorical columns, different one-hot encodings, embeddings, and so forth. But it was interesting to see it from the TensorFlow TF dataset perspective. I like that. Cool. Then we switch gears a little bit again, more of like how do we optimize our pipeline? How do we make sure that the GPU is continuously being fed with data and we don't have any bottlenecks in terms of the CPU providing all this data? I think Dimitri covered this session. It was an interesting one on optimizing our data pipeline. We talked a little bit, I think, Robert, you did this on TensorFlow Hub. And
yeah, this jumps into course 4 now, which is advanced deployment scenarios, I think. once you've learned the introductory material from the first 3, maybe introductory is the wrong word because this is already after the multiple other TensorFlow courses that we've taken.
Right.
But just a very basic intro to a number of other things that are very useful in the TensorFlow ecosystem. This course covered TensorFlow Hub. What other topics did we cover in this course? There were a handful of others. Serving. TensorBoard.
Yeah. Yeah.
And federated learning.
Yeah. It's an interesting one because you don't have to develop the model yourself, right? You can just go to TF Hub and pick the right model for you and basically do transfer learning from there. And there's different domains you can take models from, different data sets you can take models from, authors, companies, and so forth. Yep, TensorFlow Dev was an interesting one as well, where you can basically publish your own findings in a public location. So if you want to share with others the results that you collected during training, you can do that on TensorFlow.dev, which is basically like a hosted version of your metrics.
Hosted version of model analytics.
Yeah, exactly. It's just public though. That's to keep in mind. So if it's private, don't share it. That was an interesting one as well. Cool. And federated learning as well, as you mentioned, Robert and David, where basically you want to collect data from different devices, but you want to do it in a way that you're preserving privacy, and if you do any kind of central computation, you're not able to figure out which device produced which data. So a lot of privacy preserving techniques. Cool. Some other resources that we covered, TF Dataset was one of them. As you can see here, there's multiple categories, right? From audio, I don't know what D4 is, graphs, image.
It's reinforcement learning.
Reinforcement learning, got it, cool. Image classification, object detection, NLP, like question answering.
More reinforcement learning.
More reinforcement learning. Structured, which we always enjoy doing structured data sets. Summarization, I guess, NLP, text, translate, video, and vision. There's a good resource on TF Dataset. And again, you can, the cool thing about this is you can just say tf.ts.load and the name of the dataset, different splits, and you have access to hundreds of different datasets. It's a good library basically of different datasets. I was exploring a little bit this one. I think I was looking at CFR 10 under image. And they have this know your data feature where I think it's a nice location of basically like high-level data exploration location where you can basically look at your data. You can look at how many outliers you have, what is the distribution, and so forth. So you have like a stats view, a browser view, filtering. You can even look at individual records, you explore correlations. So let's check it out. This is a new resource to me as well. So we're looking at this CFR 10 dataset here of 60K 32 by 32 color images in 10 classes. It's a very classic one. There's 50K training and 10K test. You can see some examples here like horse, ship, deer, frog, and so forth. But this resource gives you a little bit of an overview of, I'm going to start a bit on the left here, zoom in, how balanced it is, right? You can see you have 6,000 records for each class, so it's very well balanced. And you have 50K training records and 10K test records. Not sure what this is. Face has faces, maybe it's looking for people or faces. I was able to identify 525 items. Image quality, exposure, sharpness, interesting. And then if I zoom in on this part of the page, you can see, you can focus probably by, I think we're looking at labels. So labels, these are, I guess, random images. Yeah, so if I'm gonna look at this one, image of a cat, you can look at all its metadata, I guess. Interesting. This one looks like it has multiple labels. Is that true? Looks like it.
No.
No? Oh,
I
Cloud
wonder
Vision.
if that's
This is
some
their
other
own.
model that's labeling it.
This is our own.
Oh, okay. So this is another model that's doing recognition, right? Or
So that model might be looking at that blue in the photo there and
Right.
saying water, electric blue.
yeah. Let's look at the ship maybe.
Is that actually the ship or was that a car?
It says ship.
Oh, that is a ship, yeah.
Yeah. Doesn't have faces. Okay.
This looks super, super useful. I haven't played with this.
Yeah, I came across it today. Yeah, I was like, okay, let me share it. I'm hoping you can do different things here, like filtering by label or by group by label or something.
And you have to upload the data to Google to use this tool, to GCS.
This one,
Know your data.
yeah, this one, when I looked at image classification, I think I just
Oh, it's for data sets.
Oh, is that what it is?
Yeah, right on the left.
Yeah.
TensorFlow data sets, I mean, that's clear that you can just,
Yeah, but
I'm assuming you can put your own data in
I
here
think
too.
it's for image related tasks as of now. I think I read it somewhere. Fairness, bias.
It's Coco.
They don't show an example here that I can see that isn't image.
Yeah. So they have like a beta going
Just
on.
like a little confusion matrix in there.
Yeah. Yeah, maybe we should check it out as part of one of our adventures. Looks interesting, right? So yeah, you can do it on what? Places, open images, ImageNet, quick draw. That's
So far,
interesting.
it's all in.
Waymo, shapes,
Yeah.
celebrities, Coco,
Surprised they don't have text.
Cassava. Yeah, right? I think they're still developing, right? So
Yeah. Okay.
cool.
Oh, we should look at horses.
Horses. I think we'll look at horses and humans enough. All right. If I see one more horse. I'm just kidding. All right. Oh yeah, from here, from image classification, see part time, it says exploring your data. So I guess if I go somewhere else, let's say Cassava maybe. Yeah, exploring your data. That was under image. So if I go under text maybe, let's go blimp. Okay, it just has information where I can find more information about it, but no exploration. Cool. Then another cool resource we saw was TensorFlow Hub, right? Where you can find pre-trained models or feature vectors for your project. So you can look at image problems, text, video, audio. And you can filter for different platforms like JS, Lite, Coral for like edge acceleration, as well as by different companies, I think, as well.
This was nice because each of these models has a number of tags and you can search by any number of attributes to find something appropriate to your problem.
Right. It's a good resource. And we also briefly touched upon Coral models, right? These are pre-trained models that are meant to run on TF Lite environment, but image classification, object detection, we didn't do semantic segmentation. Pose estimation looks interesting, and speech recognition as well. This is interesting. Cool. That was the different resources we covered, and as always, we didn't cover in this specialization, but we always look at Kaggle as well. So Kaggle datasets is also really good resources and different cool, interesting datasets from any domain of deep learning and data science, computer vision, NLP, structured data, you name it. So that's another one. I was just browsing, looking around, looking at this quick draw sketches. It reminded me of the project that you covered, Robert, where you draw something and the model is supposed to recognize what letter or what number that is.
That was the handwritten digit tf.js task.
Yeah, so I guess it's like more a general version of it, where it's supposed to identify.
It's supposed to read text?
read text, or I think you draw something, and it was an internal project within Google Creative Lab, and I think so. Let's say there's a keyword, let's say nose, and actually the drawing latitude and longitude, I guess.
So you could play Pictionary with your deep learning models.
Right.
Is that the idea?
So if you can draw something, the model can tell you what it is. Right. I like the other cool part though, where you type what you want and it draws it for you. Right. That's one of the generative part, I guess.
That is cool.
Yeah.
Especially if it draws it in a way that artist with a single pencil might draw it too.
Nice.
Not an actual image generation.
A lot of tweets. I think this is an interesting data set with tweets from Tokyo as well. I was trying to see if there's anything of we can use here. It doesn't seem, look at all columns. It doesn't seem labeled though. So it has about 63,000 records, user location, description of their profile, how many user or friends that tweet, user of Twitter has, then the date of the tweet, the text of the tweet, some hashtags they use. But then that's about it, like how many times it was retweeted, what device they used, and I don't know if, like some of the tasks that this author is mentioning is, can you identify the sport or the event that's taking place here?
Now this is just a data set that's uploaded, right? Not with a specific competition or even a specific task suggested.
Correct. Yeah, this is just a simple data set. And let me go back to the main page here. How do I go back? I guess like this. Yeah. So topic modeling, we haven't done that. Sentiment analysis, we've done that. Can you identify tweets about certain sports, countries, athletes? I don't know if we can do that. We have to find like a data set that's tuned for like specific field, right? Like sports.
Well, this would be a really interesting data set to look at from a language perspective, right? There's going to be tweets in so many different languages.
Yeah.
And can you do better in one language versus another?
I think I saw some in other languages as well.
I think I saw Chinese. Yeah, there's
some
Sanskrit,
Hindi, right? Yeah.
Hindi. Yeah.
Well, but sports, right? How do you? It's a mixed mixed ones. Because they don't mention sports specifically, right? They might mention the name of the athlete, maybe, or the name of the maybe country, or. But I don't see like a clear like
soccer,
track
and field,
okay.
There's things.
Podcast, Olympic sport, okay. Oh, that's the user description. Sorry. Here. Congratulations. First round.
Gymnastics.
Oh, you saw gymnastics?
Yeah, down below.
Oh, yeah. So it's very keyword based, I guess, right? It's tweets are so short, right? What was it, 160 characters that it's very hard to identify the content. Yeah, so make our country proud, and the country is in emoji. I guess it's here as well. Yeah. Another one is, I don't know, I came across this visa petitions as well. That was interesting as well. Someone who's gone through the process. This landmark data set that Google has, I don't know how up to date it is, but basically, given an image, can you identify what landmark it is? Like we were earlier at the National Mall, and yeah, it'd be nice if we could just point at a different, monuments. I mean, the classical ones should be able to identify, but maybe the smaller ones, or maybe if you go to a museum or a painting, like a gallery, maybe if you can point at it and you can tell you what that piece of art is, that'd be cool, right?
Or even if it's something it doesn't recognize, if it could tell you whose style thinks is most likely.
What era? Nice. And I'm going to end with one more. This is a video I took on a store in here, Washington, D.C. at Logan Circle. Right, friends. We're at Logan Circle here. This is Amazon Fresh store we just opened up. So this is a store called Amazon Fresh, which is basically a grocery store from Amazon. Suppose that you just scan your code here, pick up items, put them in your bag. There's nobody here to check you out. It's automatic. Check out their computer vision system here. So yeah, you just pick items, put them in your bag. You just cannot scan your QR code as you enter. So that's how it identifies you.
So it actually watches you put the items in the bag.
Yeah. Back end. So it's gonna upload. I thought the cameras were behind the items. That's where I put them. You know, like as a newbie here, like in terms of grocery store. Interesting how that works. But then I realized that's not where the cameras are. Let's check it out. Cameras are actually above you. Yeah, which I find really interesting. Alright, friends, we got some cherries here, 1 avocado and 1 peach. Very specific. Okay, a bag of cherries, 1 avocado and 1 peach. That's all I got.
Well, it's a good thing you wear your sunglasses in there so they won't identify you.
Oh, really? There's nobody here. We're just gonna walk out. Hopefully, the computer vision cameras here picked up everything. Now I'm gonna pause again. Thanks again. All right, let's check it out. So cool. No lie. Thank you. Appreciate it. Thank you. Have a good day. All right. Looks cool. Peace. Right. So yeah, that was our charge. 1 avocado, bag of cherries, and 1 peach.
Nice. Now, does it work for
no tax.
Charging by?
This is food, I guess.
Oh, no tax?
Yeah.
I'm surprised why.
Oh,
food doesn't have taxes?
I don't know, the district, do they not have?
No tax on food.
In the district?
Yeah.
Some places don't, some places do. So the district has no tax on grocery items, food.
Right. Same with Maryland.
Okay,
yeah, in Virginia it's 6% regular tax, but 2.5% I think on grocery items.
Yeah.
So it's a lower rate.
It tells you my trip time as well. Like that was interesting.
Oh wow. They're tracking you just like the drivers, I guess.
Right.
Now,
We got some.
What I thought might be interesting is does it work for items that they have to measure the weight as well?
Yeah, that's what I was wondering as well. That's a friend of mine what they said, but I didn't see any items that you had to wait, so they didn't start with that challenging problem, I guess.
Mm-hmm. So wait, this is like you pick these things up off the shelf. It's like watching you as you take it off the shelf, and and it's tracking you as you walk through the store.
Exactly, yeah. So I'm pointing. See this array here on top? That's where the cameras are on top. There's multiple of them. It's like an array of them.
So can you make returns then? Put an item out of your bag and put it back on the shelf, and that works too. A friend of mine went there. She did this. She put an item in her bag. She didn't like it. She put it back. She walked away. She put it back, and then she went off. And then she saw she wasn't charged for it. And then 3 hours later, she was charged for it. So I guess there's some kind of process that reconciles with how many items are in the store and how many items the people buy. Interesting.
I would wonder how well it would do if the store was really jam-packed, crowded with people, and the cameras, there's occlusion and stuff. People are coming in and out of the camera, and everybody's like reaching for the same item. 2 hands are going for the same. I wonder how it does.
Right.
So Amazon's picking the right time to test it. Then the pandemic with the.
Yeah, I mean, if it's only if it's light traffic in the store and That's crazy. Wow.
Yeah. There's not a lot of stores actually.
They're opening one up in Gaithersburg, I think.
Most of them are in California.
Okay.
I've been testing it for a while.
So when you say Amazon Fresh grocery stores, are all the fresh grocery stores like this automated?
Yeah. So California, Illinois, Virginia, DC.
Franconia. Okay.
Yeah.
And then Washington, D.C., just the one in Logan Circle.
Yeah. That was a cool one. Cool. All right, friends. I'm gonna.
Can you check?
Yeah. Go ahead.
Can you check at any time what is your balance? What's in your bag? Or what Amazon thinks is in your bag?
I don't think you have like a virtual shopping cart. Yeah, that'd be cool. No, I think they maintain it internally. So.
It seems like an obvious thing to do, though, is to give you access to that information while you're in the store.
maybe people might, try to break it or something and misuse it. I don't know. Yeah, that was very interesting. Cool. So this was a summary of the different resources we saw. I wanted to record this session because I wanted to share with our community as well online. I'll stop the recording. We're going to open a discussion for like different projects we can work on as a community. But thanks again, everyone, especially you guys joining us from YouTube. Thank you, everyone, for joining us online. And thanks, friends, for being here in person. See you on our next adventure, friends. I'll just stop the recording, but the session will go on, okay? Cool.